DJA 3032 Internal Combustion Engine. Chapter 1 Types of Engines. Engine, a device which transforms one form of energy into another form. Heat engine, a device which transforms the chemical energy of fuel into thermal energy and utilizes this thermal energy to perform useful work, mechanical energy. Internal combustion engine is a combustion of air-fuel mixture take place inside the combustion chamber. For example, gas turbine engine, Wankel, gasoline engine, and diesel engine. External combustion engine is a combustion takes place outside the engine. For example, Stirling engine, steam engine. They have two types of ignition for internal combustion engine. The first one is spark ignition, SI gasoline or petrol engine. SI engine starts the combustion process in each cycle using a spark plug. Spark plug gives a high voltage electrical discharge between two electrodes, ignites the air-fuel mixture in the combustion chamber surrounding the plug. The second one is compression ignition, diesel engine. The combustion process in a engine starts when the air-fuel mixture self-ignites due to high temperature in the combustion chamber caused by high compression. Engine cycle can be divided into two types, 4-stroke and 2-stroke. For both engine cycle, it can divide into gasoline or Otto cycle and diesel cycle. 2-stroke engine. The 2-stroke engine employs the crankcase as well as the cylinder to achieve all the elements of the Otto cycle in only 2 strokes of the piston. Intake, induction for 2-stroke engine. The fuel-air mixture is first drawn into the crankcase by the vacuum created during the upward stroke of the piston. The illustrated engine features a poppet intake valve. However, many engines use a rotary valve incorporated into the crankshaft. Compression. The piston then rises, driven by flywheel momentum, and compresses the fuel mixture. Power. At the top of the stroke, the spark plug ignites the fuel mixture. The burning fuel expands, driving the piston downward, to complete the cycle. Exhaust. Toward the end of the stroke, the piston exposes the transfer port, allowing the compressed fuel-air mixture in the crankcase to escape around the piston into the main cylinder. This expels the exhaust gases out the exhaust port, usually located on the opposite side of the cylinder. Unfortunately, some of the fresh fuel mixture is usually expelled as well. Since the 2-stroke engine fires on every revolution of the crankshaft, a 2-stroke engine is usually more powerful, lighter, simpler construction. Unfortunately, most 2-stroke engines are inefficient and are terrible polluters due to the amount of unspent fuel that escapes through the exhaust port. 4-stroke engine. The 4 strokes of the cycle are intake, compression, power, and exhaust. Each corresponds to 1 full stroke of the piston, therefore the complete cycle requires 2 revolutions of the crankshaft to complete. Intake. During the intake stroke, the piston travels from TDC to BDC, with intake valve open and exhaust valve closed. Volume in combustion chamber increase, which in turn creates a vacuum. Pressure different from atmosphere on the outside and vacuum on the inside causes air to be pushed into the cylinder. Compression. When the piston reaches BDC, the intake valve closes and the piston travels back to TDC with all valve closed. Piston will compress the air-fuel mixture, raising both the pressure and the temperature in the cylinder. Power stroke. At the top of the compression stroke, the spark plug fires, igniting the compressed air-fuel mixture. As the fuel burns, it expands, driving the piston downward. Exhaust. At the bottom of the power stroke, the exhaust valve is opened by the cam lifter mechanism. The upward stroke of the piston drives the exhausted fuel out of the cylinder.